Jai Hind everyone. I am Ankita Sharma, working as an assistant professor in EC department in Ajay Kumar Garg Engineering College. Today we will be discussing our complex topic number 3, that is addressing modes of 8085, and the subject code is KEC 5032. So before knowing the addressing modes of 8085, we should be aware about the some instructions and the instruction formats and instruction sizes. Otherwise, we can get confused with the addressing modes. So first of all, what are instruction and data formats in 8085? With this, each instruction has two parts. So first part will be our opcode and second part will be our operand. So what is opcode? Opcode is basically the first part of the instruction, or we can say the task or the operation that we have to perform. So opcode is generally called as the operation code. It is known as the operation code, and the short form derives from here only, the opcode. The second part of the microprocessor 8085 instructions will be the data on which we have to operate. The microprocessor have to operate on the data. It is called as the operand. So there are two parts of the instructions. The first one will always be our opcode, and the second part will be the operand. Next, now instruction size. So depending upon the type of operands, the instruction may have different sizes, and depending upon the sizes, there can be three types of instruction sizes here. So 1 byte instruction, 2 byte instruction and 3 byte instruction. So we will discuss the 1 byte instruction. So we have discussed just now about the opcodes. If the microprocessor 8085 instruction is having only the opcode, if there is only the opcode or some register given, no 8-bit data and no 8-bit some data, and 16-bit address is given, only the opcode or some operand, that is register only, no numeric number you can say, or no 8-bit data is given, no 16-bit address is given. At that moment, the instruction size will be of 1 byte. Typically, all instructions occupy 1 byte, and that 1 byte is for the opcode. So we can also say that this opcode is of 1 byte. We can say this also, that opcode is of 1 byte. Next, the instructions that include immediate data. Now, what do you mean by immediate data? Suppose we are having an instruction. The instruction is MVIC, 10H. So this is an instruction, and for this instruction, this MVIC, this will be the opcode. Opcode is our operation code. Through operation code, the microprocessor will get to know which operation the microprocessor have to perform. Here, MVI means move immediately. You will get to know all about these instructions in the instruction set as well. But for the reference purpose, here I am just discussing few instructions just for the reference purpose, so that we can just cover all the instruction sizes here. So MVIC, this is the opcode, and here this 10. So this instruction basically tells that this 10C, 10H we have to transfer to register C. So after this instruction is there, so C will be of 10H. So this 10 is of 8-bit. 2 hex numbers is 8-bit data. So when we have 1 byte of opcode and 1 byte of data, the instruction is of 2 bytes. Now next, if the instructions that include a memory location, Memory location is of 16-bit in 8085. If the instruction include a memory address that will occupy 3 bytes. How? 1 byte is for the opcode here, 1 byte is for opcode, and the remaining 2 bytes will be for the address. The address is of 16 bits and 16 bits is equal to 2 bytes. So we can have an example of this also. Suppose we are having LDA 9000H. In this instruction, we are having a opcode and we are having memory address. So this opcode is of 1 byte. This is our opcode. And this is operand. And what is this operand? This operand is the 16 address. 1 byte and 16-bit address. 1 plus 2. This instruction will be of 3 byte. So 1 byte, 2 byte and 3 bytes. If we review this, we can say that, if we review this, so 1 byte will have only the opcode. This can be a representation for this. 2 bytes will be opcode and operand, but the operand is of 8-bit, and for 3 bytes it can be written as opcode, operand and operand, and this operand will be 16-bit. Each block byte here, so it will be of 2 byte. So it will be 3 byte instruction, 2 byte instruction, and it is of 1 byte instruction. Next, now there are different types of operands in the microprocessor which can specify the different ways. So first of all, there may not be any operand. If there is no operand, it will be called as the implied operand. Suppose we are having this instruction CMA, there is no operand in this, it is only opcode. We can take some other examples. HALT, NOP means no operation, EI, enable interrupt, disable interrupt, and many other instructions are here. So for this is complement accumulator. So this instruction explain the operation itself. Complement accumulator, we have to complement the accumulator, and what will be the complement? 1's complement. Zeros will be converted into 1, 1 will be converted into 0. Next is HALT, we have to stop the program. HALT, no operation is going, no, enable interrupt, disable interrupt. So if we look here, there is no operand given, so this will be implied operand. Next, the operand may be 8-bit number. We have discussed just a previous slide, MVIC10H. This was our opcode, and this is an 8-bit data. If in the instruction itself an immediate data is given, means we have to transfer this. Directly we know what we have to transfer, immediately we can transfer. So that is why we can say it is an immediate data, immediate operand. Next is the operand may be an internal register. So before going to the internal register, we must be aware about the number of registers in microprocessor. How many registers are there? General purpose register, special purpose register. So if the instruction is register based, the operand will be a register, like sub B, subtract B. We have to subtract the contents of register B from the contents of accumulator. Now the operand may be a 16-bit address, that we can say memory address. So the operand is of memory address type. So there are 4 types of the operands: implied operand, immediate data, register operand and memory address. So all the instructions are based on these 4 types, and addressing modes are also the way by which we can get to know what kind of instruction is this. So these are some registers. Let's have a quick recap about these, as we have discussed in 8085 architecture as well. These are the registers of 8085. There are 6 general purpose registers: B, C, D, E, H and L. Every register is of 8 bits, and if we need 16 bit, then we will be combining these registers by making pairs. So how many pairs were there? B, C, D, E, H and L. 3 registers pairs were there, and these are fixed. We cannot combine other registers with each other. These 2 are index register, stack pointer and program counter. Accumulator is a special purpose register. All the result of the instructions of the arithmetic and logical operations, the result is stored in the accumulator. And these are the flag register. There are 5 flags. We have also discussed this in the architecture in detail also. Now addressing modes. Microprocessor execute the instructions stored in the memory, and it executes one instruction at a time. It's not possible that we are having a program of 5-6 instructions and the microprocessor will process all the 5 instructions at a time. No, it is not possible. The microprocessor will execute only one instruction at a time, and each of the instruction contains operations and operands that we have discussed just now. There will be some opcodes, there will be some operands, and the operation specifies the type of the action which the microprocessor have to perform, and there are different types. For example, I have just taken these types: addition, subtraction. Data transfer instruction is move, increment, load and store. So these are few actions that are, or we can say operations, that microprocessor can perform, and there are many other also. So operands are the data on which the operation is to be performed. Next, here are 2 examples by which we can relate with these points. So first is move B comma E. Here in move B comma A, the content of register A will be copied to register B, and here move is the operation and B and A are the operands. So this will be our opcode. Add and move are our opcode, and these 2 are our operands. So this add is a opcode and this B and B operands. So here add is the operation and B is the operand. So operand can be placed in either of the processor register or in the memory. There are 2 places where this operands can be placed. One can be the register and another one can be the memory. So there are different ways by which we can get the operands, and here are the ways to transfer the data from. We can transfer the data from one register to another register. For example, we have discussed just now move A comma B. Here the data is transferring between 2 registers. No data is given directly, not immediately. It is happening between 2 registers. So this is register based. Only registers are included here. So the content of register B will be copied to register A. Next is from the memory to the register. The data is copied from the memory to the register, like LDA, load accumulator directly 1010. So the contents of 1010 will be copied to accumulator, and next from the register to the memory without any change in the content. Suppose I have to move data from accumulator to some address. to some memory. So store accumulator, the contents of accumulator will be copied to this. We will be discussing this in detail in the addressing modes. So next is the addressing mode. The microprocessor has different ways of specifying the data for the instruction, and these ways are the addressing modes. So microprocessor 8085 basically have 5 addressing modes. First one is the immediate addressing mode, register addressing mode, direct addressing mode, indirect addressing mode, and implied addressing mode. First of all, we will be discussing about the immediate addressing mode. What is an immediate addressing mode? When the data is given directly, the 8-bit data is given directly, which we have to transfer. Register addressing mode is when the registers are given, no data or no memory address is given. Third one is direct, when we have to directly transfer the data to that memory location, and the particular memory location on which the data have to transfer is mentioned in the instruction itself. Next is indirect. In these two instructions, there is a basic difference. This will also load the contents of accumulator, and this will also load the contents of accumulator. But there is a difference. The memory location here on which the accumulator contents will go is given directly. Like accumulator contents will be copied to location 4000. It is given directly. But for LDAX, X here is extended pair of what register? Which register? B register. And what was the extended pair for B register? It was C. So B-C pair will be having some data, and when we combine two registers, they carry 16-bit. So B will be having, suppose B is having 5-1 and C is having A-E. Or we can say, we can take a simple memory location like 2005. Suppose microprocessor is having, BC is having 205. So at 205, there will be some data in the stack, in the memory. At 2005, there will be some data. Suppose it is 19. So this 19 will be loaded to the accumulator. And here at 4000 also, there was some data that will be loaded to accumulator. So accumulator is loading with the data, here directly because the memory location is given, here indirectly because the memory location contents are with the register pair. And last one is the implied addressing mode. In this addressing mode, there are no operands. So the register B and C will be having these contents, and these contents will have an address, a data of 8-bit. This 8-bit data will load the accumulator, and these two registers will have the memory location for the accumulator. Next is our implied addressing mode. Implied addressing mode means the operation the microprocessor which have to perform is given directly in the instruction. Suppose this is CMA, is complement accumulator, is given directly here. So the complement accumulator means the accumulator's contents will be complemented. And what do you mean by complement? 0 is converted to 1 and 1 is converted to 0. Complements. So let's discuss these addressing modes in detail. First of all, the immediate addressing mode. The operand is specified within the instruction. The operand itself is provided in the instruction rather than its address. So when the operand is given directly in the instruction, for example, MVIA 15H. So what we have to do? We have to move this 15 immediately in accumulator. So the data given here can be directly and immediately, not directly, immediately moved into the accumulator. So that's why it is an immediate addressing mode. Next, ADI. ADI instruction means add immediately. Like in add immediately, or add instruction or arithmetic and logical instruction, one of the operand is fixed, and that is our accumulator. So that is why you will see in every arithmetic and logical operation instruction, there will be no two registers or no other register will be given. Suppose here also it is ADI 3E. The register is not mentioned, and this instruction explains add immediately 3E. So the 3E content, this is a data, 3E data will be added with the accumulator, and suppose accumulator is having 1 0. So this 3E will be added with the accumulator, and the result is also stored in the accumulator. So this is the immediate addressing mode, where we have to perform an immediate operation immediately, as the name suggests, immediate. So that is why immediately move, immediately add. Next, register addressing mode. Here no 8-bit data or none memory address is given, only the operation is happening or the transfer is happening or anything is happening between two things, and these are registers. So registers will be involved in this. Like here the operand is specified within one of the register pair, one of the registers, and the instruction specifies the register in which the operand is stored. If we talk about this instruction, move A comma C comma A, or we can take another example as well, move B comma D, we can say this. So the contents of here register A will be copied to the register C, and here the contents of register D will be copied to register B. We can write it as this way also, destination register and source register. Next, here in move C comma A, C is the operand which specified in the register. A is the register, sorry, and here B is the operand, because B will be transferring here. So add A comma B, B is our operand, and here you can see only one register is given, add B. There is no second register, no immediate data given, but only one register. That I have told you also. One of the operand is fixed. Which operand is fixed? Accumulator. So if add B is written, that means it will perform A plus B, and the result is stored in accumulator only. So this is based on register, that is why it is register addressing mode. Now direct addressing mode. The instruction specifies the direct address of the operand. The memory address is specified where the actual operand is. So there are two examples for this: load accumulator and store accumulator. First we will be discussing about the load accumulator. This example here, what will happen, it loads the data from the memory location to accumulator. This is the memory location, and the data of this memory location will be loaded on the accumulator. Suppose this location is having some data, 8-bit data obviously. So this 8-bit data will be copied to the accumulator, and here in store accumulator, directly the address is given at which the microprocessor accumulator will store. So the data of this accumulator will be stored to this memory location. So in both these instructions, the memory address is given directly on which the microprocessor accumulator will store the data and through which the accumulator will be loaded. It is given directly. Let's take an example for this. We can be clear about this here from here. So LDA 2805. The contents of, first of all, just look at this. It is a 16-bit address. So that means this 16-bit address cannot be copied to accumulator. So that means it must be having an 8-bit data at this location here. 2805 is having an 8-bit data, that is 5C, and this 5C will be copied to the accumulator. It will only be copied here. Next is store accumulator. The contents of accumulator will be stored at this location. The accumulator is having 9B. This location is empty right now. What is happening? This location is empty right now. So the contents of accumulator will be copied here. So you can see here the contents are copied directly to this memory location. Now next is indirect addressing mode. Likewise, in direct addressing mode, the address was given directly, but in indirect addressing mode, it is not given directly. It is not given directly. The instruction specifies the indirect address where the effective address of the operand is placed, and the memory address is specified where the actual address of operand is there. For example, move A comma M. Now what is M? It is not a register that we have studied. Then what is this M? So M is used as the memory pointer and it points to some registers and H and L. So memory means M will point the contents of HL pair, and the contents of HL pair here, like the contents are 2802. So the contents 2802 will act as a memory location, and this memory location will be having an 8-bit data, and that data, 8-bit data, will be moved to the accumulator. So it moves the data from the memory location specified by the contents of HL register pair. Next, we can look here in detail. Suppose 2802. So 2802 were the contents of this, and 2802 is having 2806. It will indirectly travel to this FF, and this FF will be copied to the accumulator. Now the last one is the implied addressing mode. Implied addressing mode is also known as the inherent addressing mode, and the operand in this is not given directly, it is in the instruction itself. There is only the opcode here. CMA means complement accumulator, CMC means complement carry flag, and STC means set carry flag. So if I look at this at this instruction CMA, so this instruction itself explains the operation complement accumulator, complement carry flag. So the carry flag will be complemented. Suppose the carry flag is 0, it will be complemented and the carry flag will be 0. And in set carry flag, the carry flag will, suppose the carry flag is 0 and this instruction is applied STC, at that point the carry flag will be set. This is a summary what we have studied right now. Immediate addressing mode, the 8-bit or 16-bit data is a part of instruction. For example, move R is a register and this register can be other registers as well, B, C, D, E or accumulator as well, and register pair can be B, C, D, E, H and L, and register both source and destination operands are specified by the registers. Move destination register, source register. Detailed example we have discussed, move B comma A, move D comma B, some other. And direct addressing mode, 16-bit memory address is directly specified within the instruction. For example, LDA and the address 1010 suppose, or STA 91AE, it is also 16-bit address. Indirect memory address is specified with the help of register pairs. It is given indirectly. The location is given indirectly here. Suppose LDAX load accumulator with register pair B, and the contents of BC is 1900, and at 1900 location there is a data that will be 8-bit data. Suppose it is 45. So 45 will be loaded in the accumulator. And last one is our implied. The opcode specifies the operand CMA, NOP, no operation, halt, all these things. So I hope you have understood about the addressing modes. Thank you.